Greetings, medics! Welcome to some worked examples for the quantitative reasoning section of the UCAT, where we're looking at ratios and proportions. Okay, looks like a meaty question. We've got a laboratory on planet Zarion, as you do, which has 3 types of energy cells, red, blue and green. And total number of energy cells is 480. The number of red cells is 40% more than the number of green cells. Okay, so let green equal G. And what we're going to do is just decode this statement here. So the number of red cells is 40% more than the number of green cells. So there's green cells and we need 40% more. Okay, so 40% of the green cells, we can represent 40% as 0.4, and it's 40% of the green cells, so that is just going to be G for green cells. So they can simplify that to 1.4 G, and that's what red is equal to in terms of G. Okay, so the number of blue cells is 60% of the total number of red and green. Okay, so let's say that the total number of red and green, and we can write these in terms of G. So red is 1.4 G and G is just G. So the total number of red and green is equal to 2.4 G. So if we have a look at that sentence, we can then say that 60% is 0.6 multiplied by 2.4 G. So what does that give us? So that will give us 1.44 G. Okay, so we know the total number of energy cells. So what we're going to do here is, it's like a ratios question. So we've got red, blue and green. So we know that red is expressed as 1.4 G. We know blue is 1.44 G and green is just green, right? So what we're going to do is just going to add all of these guys up, but they're all in terms of G, so no dramas. So if we add all these up and equate it to the total, then we should be in business. So if we start breaking this down a bit, 1.4 plus 1 is 2.4, and 2.4 plus 1 is 3.4, and then I need to add on the 0.44, so that should be 3.84 G, he says. And that is going to be equal to the total number, which is, so 3.84 G is equal to 480. So then we can say that G is equal to 480 over 3.84. I'm going to use my calculator here, obviously. So you get the calculator up and do 480 divided by 3.84, and you should get a 125. So that is 125 green. Okay, so what else? So we also know that the number of blue cells is 1.44 times G. We know that. So blue is equal to 1.44 times 125. So what do we get? So we get 180. Our blue, and we're asked for the proportion of the total number. So that is going to be blue divided by the total number, which is 480, which gives us, and let's divide that by 480, 3 over 8, so 0.375. Bingo. Lovely question. Okay, question 2. So in a chemical storage facility, there are 3 tanks A, B, C containing a liquid compound. Okay, could do it through proportions. We could, and you could do it algebraically. I'm inclined to do it algebraically. So tank A holds 25% of the total volume. So let tank A equal A. So tank B contains 40% more liquid than tank A. So we can say that tank B is equal to tank A plus 40% of A, which we can express as 0.4A. So 1.4A in total. And then tank C contains twice as much as tank B. So C is equal to tank B times 2. Now we already have an expression of tank B in terms of A. It's 1.4A. So if we substitute that in for B, we can then say that 1.4A times 2 is equal to 2.8A. Okay, so where do we go next? So we want the fraction of the total liquid in tank C. So fraction of the total liquid is in tank C. So C as a fraction of the total. Okay, cool. So then to get the total, it's just going to be A, B, and C. So A is A, B is 1.4A, and then C is 2.8A. So if we add these up, what do we get? So 2.8 plus 1 is 3.8. So plus the 0.4 is 4.2. Okay. So that is 4.2A. And remember, I've got 1A here. So 1A plus 4.2 equals 5.2A. Okay, so that is my total. I want the fraction of the total liquid. So what fraction of the total liquid is in tank C? So that's going to be tank C over the total. So what is tank C? Tank C is 2.8A. The total is so what does that give us? Now you might be inclined to use a calculator here, and I probably wouldn't. What I do is times the top by 10 times the bottom by 10 to give us 28A over 52A. So the A's nicely cancel out, and then I'm left with 28 over 52, and it's not as bad as you think. So if we divide that by 4 and divide the denominator by 4, so 4 goes into 28 7 times, and then 4 goes into 48 12 times, and therefore it goes into 52 13 times. So the total fraction is 7 over 13, and bingo. Question number 3. Hopefully it's not going to be as meaty. So to get to the gist of it, we've got some applications received and the students accepted. We want the simplified ratio of the total number of students accepted to those rejected. Okay, cool. So could have another column here for rejected. Okay, so where do we go? So total number of students accepted to those rejected. Okay, cool. So that isn't too bad. So therefore 180 received, 100 accepted, so rejected must be 80. So that is 80 as well. That is 80 as well. That's 80 as well. And that's 80 as well. So total rejected is 5 lot of 80. So 8 5s is 40. So that is 400. Okay, so now let's have a look at total accepted. If you have a look at total accepted, that's 200. That's another 200, and that's 100. So total accepted, if you add all of these up, is 500. So what's the simplified ratio of accepted, total accepted, which is 500, to total rejected, which is 400? So then dividing by 100 on both of them, you will get 5 to 4. We'll just add it in. So 5 to 4 is the ratio, so therefore the answer is B. Final answer. See you around next time.